All right. So, bam! Dev to the future, improving developer experience. That's how I'd like to come in. Actually, I prepared choppers and fireworks, but that didn't work out for today. So, if the first row, we're gonna just practice. I'm gonna do some fireworks, and you're just gonna get startled, okay? Be careful, it's hot. Right. So, dev to the future. Improving developer experience. Something that we've been doing since the first computer ever was invented. Because it was too big, then it was too slow, then it was too complex. And we're now in 2023 and we still think it's too difficult. It's weird, huh? Doesn't it? We improve things and yet we find out that it's still too slow or too complex. So before we dive in, I'd like to ask you a question. Well, you've heard today, this year, that platform engineering, reducing cognitive load, these are all hype terms, aren't they? So, but what do we actually mean by them? So that's why the question: what is one of the misconceptions of reducing cognitive load? At the end of the presentation, I'll come back to you, so you better pay some attention. And if you get it right, you get a T-shirt. All right. My name is Kasra Amirsarvari, working at the IT consultant at HCS company, currently in the role of platform engineer. But I've come from a long way of system administration, Linux engineering, basically all kind of engineering just to be able to pay my mortgage. Right? So probably next year I'll be doing something else until I pay off my mortgage. So one of the things I'd like to do is I just love to see tech work and people thrive. This is one of the major things I'm fond of. So please let's connect and talk more on this after the presentation. So some of the things we're gonna touch today, of course, platform engineering, right? Exclamation mark. What does it actually mean? How does it relate to DevOps and SRE? The developer experience. What is that? So on the bottom side, I'm going to come in with platform engineering, and from the top, we're going to go with the developer experience, and somewhere in the middle, they're going to meet. Magic is going to happen today. And then we'll just finish off with the avalanche of tools. I mean, these days, there are so many tools. Which you're going to choose, and why? So what is platform engineering? Well, it's basically to build, operate, and maintain the infrastructure and tools for efficient software delivery. Because let's be honest, a platform is not just to become just a ghost platform, is it? Something's going to run on it. So this thing has to be made in order for people to make use of it. And who are these people? Mostly developers. Can you consider this platform as a product? I think so. And these developers, they're kind of like your internal customers, aren't they? They have expectations, and you have to comply. Well, one of the things is that with platform engineering, you're basically abstracting complexity, because things are always complex. The amount of tools, you just want to abstract all the complexity away from it, as much as you can. You want to alleviate the burdens and chores for your internal customer, because if they want to use these platforms, and believe me, you as a platform engineer is going to dog food your own platform also, because you're going to be benefiting from it yourself. You want to alleviate all these burdens and chores. And your main goal is focus on quality software development. I mean, it's not just to make the most sexiest platform ever and then have everybody look at your nodes, look. Well, what does it actually do? So your purpose of having this platform is so there's software being built and written and run somewhere, most likely Kubernetes. So just as a side note, sidestep, I used to create VMs, virtual machines, and I was really good at it, automating things, zero-touch provisioning, it was really nice. But at the moment that I had to give it away to a database administrator or anything, I would get sad. Because this nice machine, this virgin machine, would get tainted. Once I gave it away, somebody's going to log into it. It's going to taint it. They're going to do things with it I didn't intend, right? What was I actually doing? a OS, a virtual machine, is also basically a platform. What my focus was completely wrong, because people are going to use it. That's why it's important to have this focus. That, you know, what are you actually making it for? Who are you making it for? So that's important to keep in mind. So what does a platform engineer do actually? Well, basically, first of all, empowers developers. That's your main goal. You empower developers. You improve efficiency and you maintain the tool chain. This is your primary goal of existence. Because, you know, you have internal customers. They want things you do, and you want to do them good. You want to do it efficiently. You want to provide at the end reliable platforms so that people can just be alleviated with all these problems they don't have to care for anymore. I mean, what about yesterday you made something and tomorrow it doesn't work anymore? What, is it something to blame to your code, or never happens? You must have an awesome engineering team, right? Waterstaat, right? Rijkswaterstaat? Yeah. They're looking for people. I heard. Yeah, and another thing is, you know, whenever you're trying to focus on something, what are you actually building? You have to collaborate. You have to know what you're actually building and who are you building it for. You have to ensure that whatever you make is aligned according to whatever consumer is on it. I mean, you can make the nicest thing, you can be very opinionated, you can be in IT since 1970 and be very experienced, but you know, again, the important thing is, what are you doing? What problems are you solving? So that's very important. So as a platform engineer, you're dealing with several things, right? So we have this DevOps, SRE, so many methodologies, am I correct? So many methodologies, practices. How do they actually relate to each other? Well, platform engineering basically provides the abstraction layer to support DevOps and SRE practices at scale. So where DevOps, in short, we can argue about this, but so DevOps, in short, bridges the gap between Dev and Ops, while SRE ensures reliable and scalable systems, where platform engineering basically is the foundation for efficient software delivery. And these three are not separated from each other. No, they complement each other. So they go hand in hand. And how do they go hand in hand? Well, let's say, if this works, these are your DevOps teams, your SREs, or your product teams, or app teams, or whatever you call them within your organization. And these are your tools, components, services, infrastructure, whatever you have. You don't want these teams to individually go around and grab whatever they want because they think that's what they need and then start doing things, right? You don't want that. Well, they might be successful at first because they're smart people. I mean, you hired them, they're expensive, they might get the job done, and then start developing. And then 6 months later, things become deprecated, you have updates, things change within the organization, rules change. Now you have to change the services that you put as a puzzle together, the collection you created. So that means that you're going to spend more time here than actually trying to deliver value. So of course they're capable, they can do it, but should they do it? I think not. Because we have a platform team on the side, and that's actually creating or using an internal developer platform, which could basically be anything, right? I mean, this is also a hype word, but it could basically mean anything. It's a piece of software that is the abstraction layer between the services and components that are within the infrastructure, basically providing them to these ops teams, dev teams, whatever teams you call them. And by doing so, they just, go to a portal, self-service thing, they just click what they want, use what they need. They don't have to care about all the other things. They deliver value, and whenever they don't need it anymore, they can just release it. I mean, how many times have you seen systems being provisioned and never decommissioned, right? I've seen them. It could be even a vulnerability, you know, if you have systems running around, you don't even know that they're running, you know, and they're just, you know, within the network, within production network, things can go wrong. So basically this abstraction layer, I'd like to say abstraction layer because that's the positive part. And then the other part is obstruction layer, right? So you abstract something for the good, but try not to obstruct. Because when you obstruct, then why did you actually start doing this? I mean, why not just say, listen, you send an email, I'll see you in 5 days, because that's the SLA, right? That doesn't work out. So another way to visualize this abstraction layer is, I like this city around here, because a city is basically small abstraction layers that we all live in. Let's say, for instance, a bakery. A bakery abstracts a kitchen, right? And whatever you do, you go there and you say, listen, I want this bread, and then you pay something for it, and then you take it, and you have so many choices, and you eat it. But you don't go into the kitchen, bake your own bread, and 6 hours later you have something burnt and now you have to eat it because you made it, right? I'm a bad cook, but it's my experience. But this happens. Now imagine this bakery being at the 22nd level of a building and the elevator is broken. So now if you want to go to your bakery, you have to walk all these stairs. And by the time you reach there, you want to buy something, you basically already used all your energy. So what are you going to do? I mean, this is not really nice, is it? This is a bad experience you have there. So it's basically going back to abstraction and obstruction. So you can abstract something, but if you put it in an obstructive way, nobody's going to be beneficial in that. So when talking experience, let's talk about developer experience, right? So what is developer experience? It's basically the overall experience of a developer when working to add value. This could be anything, but they're just working to add value. And again, this is not something new. It's comparable to customer experience. I mean, you yourself are a customer somewhere. You take services, you pay for them. And what do you do when they're unavailable for you at the moment you need it the most? You have bad experience, you get unsatisfied. You go on X and then say how shitty they are, right? On a pseudonym, of course. Because you don't want them to actually know that's you. So that's basically developer experience. It's nothing new, but it's just the experience the developer has. And the developer is your internal customer, so remember that they also have a certain experience and expectation. So you want them to have things that that are easy to use. You want them to have available and accessible things. You want to provide the support and the documentation for that, because if you don't, things get fuzzy and the experience degrades, and you don't want that. And at the end, it's about the quality of the experience. And when talking about experience, well, these two things, what I just talked about earlier, they meet someplace. So you have developers from one point of view and then the platform from one point of view, and they benefit from each other. As I said, I mean, if you're a good platform team, then you're also developing. So these tools that you're making, you're dogfooding yourself. And on the other hand, you have these developers that actually create services. They benefit from the platforms that you build using basically the same methodologies, right? So it's about consistent and reliable platforms. Having them built with built-in automation, so you don't have to care for that. Having as-a-service capability, so whenever they go, think of bakery. What do you want? Cornbread, you want whatever kind of bread, white bread, brown bread, croissants. You want them to be there available as a service. Anybody getting hungry? I do. Shows, right? So make sure that you have this supply and demand. Ask them what they want and meet that demand. Have them up to date and accessible. That's what benefits from each other, right? Having the support and nurture. Nurture is kind of a thing, you know, Again, for the third time, a father. So I nurture. That's basically a thing that's dear to me now, more than ever. And mostly, when you support and you nurture, it's basically about like-minded people that work towards the same goal. You're doing it for the same goal. Remember when I just said, it's my VM, not yours, and whenever you log in, you taint it? That's a wrong goal. But, at the end, you want the whole team, the whole company, everybody, all the teams, you want them to work towards the same goal. It's not going to be easy. Nobody said it's going to be easy, but it's going to be your goal. Because if you work towards that goal, trust me, you will achieve it. Humans are capable of great things. And whenever we talk about these humans, what matters most? People. You, everybody here matters. Because first of all, you're a human. You deal with other humans. So yeah, that's the first thing that matters. Technology is actually, that's fun, fun and games. Yeah, most of the time you spend your time with it in front of a screen or whatever. But at the end of the line, people are important. And after the people come culture, because if you put people together, you create culture, and this culture is important. Have them focus and align together. Collaborate. Bake these communities. And of course, as I said earlier, it's about the developer-centric approach. When everybody works towards the same goal, what is your goal? Make sure that these developers can create awesome things so the business can thrive, so you can probably make more money. That's the end of the game, right? I mean, you also have a mortgage to pay, right? And you want to have fun while doing it. And as I said earlier, if you want to solve something, make sure you know what you're actually solving. So ask the right questions and address them appropriately. If you don't ask the right questions within these teams, if you are not honest in the community, if you don't say what you actually want, you will not get what you want. You will get something that you probably didn't want. It's not going to work for you. Be honest, be open, straightforward. You might break some feelings because, IT people have strong opinions. Yeah, sure, but be honest. Because first place, you have to be able to add value. You're not just there to have fun. Also fun, but also make money. Or provide services if you're a government organization, of course. You have fun too, right?
Very much.
Very much. Do you actually get to work also? Yeah.
What?
Yeah, that's actually the best response I got today. Nobody wants to work. Why? You want to automate everything so you can put your feet up, right? You want a pedestal to put your feet up? So one of these things that actually, besides what matters most, is the time that you spend on it. The time that you have to spend to actually start creating value. So whatever you need to get up and running. The time you need to learn and understand new things, new concepts. Somebody thought of something new, now you have to learn it. I mean, after school, I went into IT, and I'm like, yeah, I'm done learning, right? No, I took the wrong choices in life there. Basically, I'm learning now more than I did at school. It's weird. When doing so, the time that you spend, also think about the feedback loop that you are spending it for. If you have a CI and you put one commit and it takes 2 hours for a whole cycle, you lost these 2 hours. Imagine you committed something with a typo, you had to wait 2 hours for it to fail, and then you can do something again wait another 2 hours. That doesn't work. Well, it works for these 2 hours, but it doesn't work for the business. And it's basically the time that you use to actually start add value. What else matters most is the tools that you have. Because tools also have value. And how do they value you? Well, basically, you choose the tools that provide you the most value. How do you choose that? Well, read, right? You have the CNCF landscape, for example. We just talked about it. It's huge. Well, how do you choose what you actually need? Well, first of all, what problem are you solving, right? Think about that. List it out, write it down. Those are your requirements. So you take them, and then you have this list, and then you ask the next question. What takes the least amount of time to get it up and running? Is it easy to use and maintain? Does it have a reliable origin? I mean, right now, somewhere, some kid is making some awesome tool that's going to solve world problems from his basement. But is this kid a good origins, a good source of origin? I mean, are you going to put your whole enterprise on the shoulders of this kid? He creates awesome tools. Yeah. Or she. So, yeah. Also think about how these tools integrate. Because you can have the most amazing tool, but if it doesn't integrate with the rest of the tool chain, now you have to make decisions. So you're going to throw away the rest of the tool chain and go for this tool. There's no one tool for all solutions, so you have to make sure that there's an integration in there. It's really important. It could even be not the best tool, but as long as it integrates, it takes the least amount of time to maintain. It's from a good origin. Maybe it costs some money, sure. But if it can help you out, why not? And talking about these tools, I'd like to highlight some tools. Well, I myself, I have a little bit of a red background, mostly Red Hat Enterprise, you know, that's where I come from at least, that's my background. So I'm very Red Hat oriented, so that's why I just took some tools that are basically coming from Red Hat. And they're doing an awesome job. So let's take the Red Hat Developer Hub. It's based on the upstream project Backstage, which comes from Spotify. Awesome tool. It's just as when you look at it, it sometimes might be a little bit too much, right? I mean, how many of you heard Backstage? How many of you use Backstage? And how many of you know how to use TypeScript? Oh, okay. You should meet the others. Exchange some information. So Backstage is basically an open platform to build developer portals. It's not like something that you install and magically everything is fixed. No, you have to do some effort. And Red Hat took it, and they have this midstream Janus project, Janus IDP. And the next stage of that is the downstream, and that's the Red Hat Developer Hub. Right now it's available as a developer preview. You can actually go to developers.redhat.com and sign up for this. I did. You have to exchange your key ID, Quay.io key, whatever. And you get access to the registry. You can basically use it within your cluster, and yeah, and already have a preview of how it's going to be. I wouldn't say use it for production. In the developer preview, things are going to change, but it's there for the best. And what they are solving, they are making sure that it integrates very well with OpenShift, as do other tools that also integrate with OpenShift, making your life a little bit more easier. The things of like being able to configure it on a Kubernetes platform. Because if you take Backstage to upstream, you have to make your own builds, you have to put your software within there, all your plugins have to be in there, and then that's your image that you create and you deploy. But what if you want to configure things, right? And with configuration maps or whatever. So that's kind of the thing that they're going towards. And it provides a self-service capability, a single pane of glass, and standardized workflows. And this is where these golden paths come from, right? Also a hype term, golden path. There's actually never been a golden path. It's very expensive. Would be better, right? But yeah, the thing is, it's very extensible. You can just make sure that everything just integrates and works well for you. To make sure that the whole view that you have is a single pane of glass. There's no glass actually used, but just figure of speech. And how does it look? Well, something like this. So you have a catalog with software components. You can add these software components through a template, and this template comprises of some stuff, basically an overview, topology, links, issues. These are the extensibilities, right? So it basically can plug into your version control where you have like your issues or anything else that you use. You can see your pull merge request. You have an overview of your CI. So everything is there. You know which Argo CD, you know which, if you are multi-clustered, it's there. You can just see it. You take a software component, no, then listen, these are 7 pods, they're running there, and they're deployed through this Argo. This is the last CI run. And the documentation, where is it? Usually nobody can find the documentation. There you go, it's there. You can even see who owns this service if you want to blame people. Open culture, be nice to each other. so basically that's just kind of like the Red Hat Developer Hub, well, coming from Backstage. And you can add plugins to make it more extensible. You can write your own plugins. It's really awesome if you have something that you know is special for you within your organization. Just write something for it, build it, plug it in, it works. Then another tool that I like to highlight is Red Hat Dev Spaces. Again, something Red Hat, but upstream it's from Eclipse Che. It's a really cool project. It's basically, I mean, how many of you guys develop and build on your local host? And how many memory do you have on your machine? 64. 2 memory? You have 2 machines?
2 memories.
Two memories. I like that. Who has more? You basically have like this giant machine, this very expensive machine, and you know you need to be able to run all these things within it. Basically, it's tainted also. You can only do probably 1 or 2 projects at the same time. You can't mix Python, I don't know, 3.8 with Python 3.11 if you didn't configure things properly. So it's not portable. So why not just use like this entire compute cluster to work in, right? You can basically have a Chromebook as your developer laptop, and all you need is basically a browser, an internet connection, and go to somewhere. That's the dev spaces. Open it up, choose a project, and then start working immediately. So these are solutions that go back to what I've said earlier, trying to reduce the time to set up. I mean, today you can work on Java project, and 5 minutes later you can work on a Python project, then you can work on a TypeScript project, and you can have all these 3 running at the same time. If you have enough resources, you can spin them up and just leave them running. It's not environment friendly, but you can do that. Actually, we run to an issue that we ran out of storage. Also something you need to think about. Don't put Red Hat Dev Spaces on your production cluster. Think about a new cluster. Things are gonna go wrong. Well, you have to protect your production workload, but this is important to think about. So with these tools, so how are you gonna use them, right? Because they might be developer centric. You think like, oh, this is a development namespace, right? But for the developer, that's basically their production thing. That's basically what they need to produce, to add value. And if that's not available, they can't work. Now they need a, I don't know, 5,000 euro MacBook, whatever, with 2 memories. Yeah, so basically this provides self-service capabilities. It standardizes production-like, so you can have whatever stuff you have in production and then have them like that, but with some additional things, so you can develop and tinker with it, make your things. This is where you have this inner circle. You can do something, build it, have it fail, and then think about, oh, why did it fail, instead of going through the whole loop of waiting 2 hours for your CI pipeline. So these are things that are all provided in here. And it provides Visual Studio Code. Any fans? Yeah? Okay. Right. It also has extensions for Vim, and anybody who develops within Vim. Right. Yeah. Sebastian. All right, so how does it work from its internals? Well, basically, you have a source version control, Git or whatever, something somewhere. This doesn't actually have to be Git, but it would be nice. I mean, you version control your things. So within there, you have a dev file. Dev file is basically a YAML file. We all YAML people here, YAML developers. And that YAML contains all these components that your project comprises of. all the tools that it needs to check out, the project that it needs to check out, the images that it's built on, the commands that people can use within their Visual Studio Code. It's all there. And then you just throw it into a J cluster. This is where magic happens. Not going to go all the way into depth on that. Could get too technical. That the J cluster is provided by the dev spaces operator. And at the end of the line, a workspace is created, which is basically a namespace. And within that namespace, you have the things that you need. Your IDE, Visual Studio Code, for example, it runs in a container. Your tools container that you basically built yourself contains all your tools. This could be a huge container if you need that to be. Persistent volumes if you need it, services, routes, and other containers that you need. So these are all defined here, and they magically appear to the right side, and then you have your workspace up and running. You can have many, many of these as much as you have resources. And then just start adding value. Just go. So in conclusion, nice timing, right? So in conclusion, there are 3 things we've learned today. At least I hope, if you paid attention. So abstract, not obstruct. Important. So yeah, abstraction in layers. Do not obstruct. Make sure that it helps you. Focus on the experience. Accelerate value, all these kind of things. Maximize the developer efficiency. Talk with them. Make sure they're happy, they're satisfied. The internal customers. Remember, you have a product. They use that. Actually, you use it too. So, and ask the right questions. If you don't ask the right questions, you don't know what you're actually solving. You don't know where you're actually heading towards. You can have a roadmap, yeah, but if it doesn't solve all these problems that you're actually having, then what kind of a roadmap is that? And then at the end, like the last bullet, what is it that you truly desire? I started off with Netflix. Who knows the Netflix series Lucifer? Anybody? Right? This fallen angel, right? So capabilities, magic, and then he goes up to somebody and then asks, like, what is it you truly desire? And magically they just say, I'd like to dress up as a woman in the weekend, all those things. So you get the truth out, right? I like that. I like the reference. Not dressing up as a woman, but maybe that too. It's between you and me, right? Yeah. So going back to the original questions, a question I asked you earlier. I hope you paid attention. Does anybody want to answer this question? What is one of the misconceptions of reducing cognitive load? Go.
When you burn your bread.
When you burn your bread. Yes. Give this guy 2 more memories. You get a T-shirt, actually, if you want. We have 2 T-shirts for you. No. What do we actually mean with reducing cognitive load? So this basically originated from this book, Team Topologies. Read it, download it, buy it, do something, read it. He's the guy who showed me Vincent, and I learned these things from him. So what did we actually learn? Reducing cognitive load, what we actually mean with that is that we want to first of all eliminate extraneous load. So cognitive load consists of 3 things. Extraneous load, intrinsic load, and germane load. You want to eliminate the first one. Why? Because you can automate that. Extraneous load, think about how can I deliver my product? How can I deploy something? How can I make the service? It's not basically what you actually need to add value, right, as a developer point of view. So you can automate that with, for example, an internal developer platform with your golden paths. You want to minimize the intrinsic load, and the intrinsic load is basically the kind of cognition that you use to actually try to solve a problem. And the more you're hassling and doing things there, the more you're using that intrinsic load, but not actually adding value. Let's say, for example, somebody made a bad architectural choice. Now you have to deal with it. You hate it, but you have to learn how it's done. You have to find out the logic. That's basically losing time. So you can minimize that by training. having pair programming, understanding each other, how to do things. So that's how you can minimize that. And another side is, the last part is the germane load. And that's, you want to just expand on the germane load, because that's basically the cognition that you need to think. That's where you add value. So if you minimize if you eliminate the first one, you minimize the second one, then you create more space for the last one, which is actually basically thinking. So whenever we go back to the reduction of cognitive load, it's not simply to reduce your cognition, because if you do that, you just become stupid. You don't want that, right? No, you want to make space for adding value. And with that, I'd like to conclude Dev to the future. Improving the...
Fireworks. Fireworks.
All right. Thank you very much. I don't know if there are any questions. If we have time for questions. Yeah. Anybody want to do questions? Anybody want a chance to? Yeah.
That's not really a question, it's more of an addition. So your platform is indeed for your customers, and it's also for yourself, your platforms. But you are also often needing a platform for your platform, because take for example your computer storage, it needs to come from somewhere. So as a platform engineer, you might be not necessarily wasting, but spending a lot of time on bringing up more nodes. And that is something that, just like all the other experiences, this is something you also should probably automate and reduce and not spend as much time on as you might be doing. We've seen a lot of, we did in the past as well, you pick your own operating system image and you customize it and you launch it and then you refactor it and then you redeploy it and upgrade it, and you spend half the time doing things that don't actually add any value.
Yes, I agree.
Yeah, and that just applies to the platform for the platform. Yeah,
Yes.
nested balls down there.
Yeah, platform for platforms. Yeah. Thank you for the addition. More memories.
More memories. 6 memories.
I think so. Yes. Thanks.
All right. We have a 5-minute break and then we have the lightning talks.